So here we have the question. Now I have illustrated the question here. We have a parallel plate capacitor, part of which is filled with a liquid. It is given that the liquid has a dielectric constant of 2 and the plate area is 1 meter square. Okay, these things are given in the question. The capacitor, part of the capacitor is filled with a liquid and the rest part is empty. Area is 1 meter square and dielectric constant for the liquid is 2. So much is given in the question. And the question is to find out the time constant if this capacitor is connected to a resistive circuit. Whenever a capacitor and a resistor are connected in combination, that's called a CR circuit. And for a CR circuit, the time constant is written as C times R. Similarly, for an LR circuit, it is what? LR circuit, inductive resistive circuit, it is L by R. Time constant is given by L by R. While for a CR circuit, capacitance resistance circuit, it is the product of capacitance and resistance. Here the question is to get an expression for time constant in terms of time or as a function of time. And there is one more thing given in the question. The water level is not stationary. It is coming down very slowly. Why? Because water is leaking out somehow and water level comes down very slowly. I can take the level at a later time in terms of time. How? You learn distance as what? Speed as distance divided by time. So if you cross multiply, you could write x as what? V into t. X is equal to V into t. So, after a time t, water level will have come down by a distance V into t. So the new water level would be Vt below this. The new water level will be Vt below the original level. So for the top capacitor, the top part of the capacitor, which is air filled, the distance will no more be 2d by 3. It is instead what? 2d by 3 plus Vt. While for the bottom part, the width is not d by 3 anymore. It is what? It is d by 3 minus Vt. Why minus Vt? Because the level has receded by how much? Vt distance. So let us find the capacitances. Capacitances first. The capacitance is given by what? Capacitance of a parallel plate capacitor is given by epsilon 0 A divided by distance. What is the distance here? It is 2d by 3. So epsilon 0 A by 2d by 3 plus Vt. Why plus Vt? Because after a time t, the level has come down to what? Vt below the original level. So the distance is 2d by 3 plus Vt. Okay, right. So 2d by 3 plus Vt. Now I can simplify this. I take 3 to numerator. That makes it what? 3 epsilon 0 A by 3 epsilon 0. I will write it below this. So I'll write it one more time. The capacitance is given by, capacitance of the first capacitor is given by, that means the air part. Epsilon 0 A divided by the distance I said it is 2d by 3 plus Vt. I take LCM here, LCM comes here, this is 3 goes to numerator. So that makes it 3 epsilon 0 A by 2d plus 3 Vt. 2d plus 3 Vt. I can substitute the value of A here. A is given in the question as 1 meter square. I'll put it here. I'll get what? 3 epsilon 0 by 2d plus 3 Vt. So I got what? I got capacitance of the first part of the capacitor. First part, no? The top part of the capacitor I got. It is 3 epsilon 0 upon 2d plus 3 Vt. Similarly, for the bottom part, I could write what? C2 is equal to. There the capacitance is what? Epsilon 0, epsilon R, A by. The distance is what now? The new distance is d by 3 minus Vt now. So d by 3 minus Vt. I'll just put the value of epsilon R here, area here. So I'll get epsilon 0. Epsilon R value is given in the question, it is 2. Area is given in the question, it is 1. And LCM, this 3 goes to numerator. 3 upon, this is what? D minus 3 comes here, no? 3 Vt. So I got my second capacitance. So I could simplify this. 3 into 2 is what? 6 epsilon 0 upon D minus 3 VT. So I got 2 capacitances now. Right. Now what? I have to find the effective capacitance of this assembly. See this? Now if I keep this capacitor in the vertical orientation, if I turn it like over 90 degree, this will be like, left part is filled with one material, right half is filled with, not half, right side is filled with another material. We have already seen that if the left part is filled with one material and the right part is filled with another material, that has to be seen as a series combination of capacitors. Left half, right half should be seen as series combination of capacitors. So I'm finding the effective. What is the effective for series combination? Series combination effective is C1 C2 by C1 plus C2, C1 plus C2. I'm just substituting for C1 and C2 here. C1 is how much? 3 epsilon 0 by 2D plus 3VT into, this is C1. C2 is how much? C2 is given 6 epsilon 0 divided by D minus 3VT divided by, the whole of this divided by C1 C2 by C1 plus C2 should be taken. What is C1 plus C2? 3 epsilon 0 by 2D plus 3VT plus, this is 6 epsilon 0 divided by D minus 3VT. Okay, so I got something like C1 C2 by C1 plus C2. Now I can take what? I can take LCM here, no? So before doing that, I'll just multiply this. 16 into 3. 16 into 6 into 3 is what? That is 18. Then epsilon 0. Then one more epsilon 0 divided by. This is 2D plus 3VT into 2D plus 3VT into, here it is D minus 3VT. Okay, right. Divided by, because I'm going to take LCM here. No, this is CS. Series combination, right? Divided by, what do we have here? What do we have here on the denominator? LCM. No, I'm keeping epsilon 0 outside. There is epsilon 0 in this term. There is one more epsilon 0 in this term, right? So I could take epsilon 0 common outside. Okay. Now what is LCM? I can cross multiply. D comes here, no? 3 into D. 3D minus 3 into 3VT. 9VT plus. Then 2D into 6. 12D. Then 3VT into 6. That is 18VT. Divided by, I've just taken the LCM here. No, the LCM is this term into this term. So I've taken this term here, this term here. That's it. Okay. So 2D plus 3VT into, this is D minus 3VT. 3VT. So I can cut this and this because we have common denominator. This one and this one are getting cancelled. One epsilon 0 gets gone with epsilon 0 here. So what are we left with now? So CS is equal to, I have CS is equal to, the effective capacitance is equal to, what is on the numerator? 18 epsilon 0 by, what's on the denominator? 3D and 12D together, it is 15D. See this, 15D plus 3D and 12D is 15D minus 9VT plus 18VT. That is 9VT. So I'll cut, I can take 3 common here on denominator. And if I do that, the numerator gets cut here. And that will give me 6 epsilon 0 divided by, what is here? What do we have on denominator? 5D plus 3VT. This is the effective combination, effective capacitance. Okay, I've taken 3 here. I've taken 3 common on denominator. That 3 gets cut. So in the end, you'll get 6 epsilon 0 by 5D plus 3VT. I'm done with the first part. Right. Second part is what? They have asked you to find out the time constant of the capacitance resistance assembly. Right. So how do you find the time constant? Time constant can be taken as C into R. That is, I could put the value of C here. Right. C is what? 6 epsilon 0 by 5D plus 3VT, the whole of this into R. So if I multiply, I'll get what? I'll get 6 epsilon 0 R by 6 epsilon 0 R divided by 5D plus 3VT. 6 epsilon 0 by 5D plus 3VT. See this? This is the final expression. Look at this. Time constant in terms of time. Time constant as a function of time. Okay. You know, the question is to get the expression for time constant in terms of time. Water is slowly coming down. Water level is slowly coming down. You are supposed to calculate. So you are supposed to get an expression for time constant as a function of time, which we have done now. Time constant is CR for a capacitor resistor circuit. Okay.